Hey everybody, so next we'll take a look at all of the solutions from the Chapter 2 sample test. Number 1 states that we are to use the conditional. Two angles are congruent if they are vertical angles. We have to write the hypothesis, and this particular one is written in a slightly different way than you might be used to. Remember that we usually see if P, then Q. Alright, and the hypothesis is P, but recall that we can also write things Q if P. And so our hypothesis in this case is two angles are vertical angles, or they are vertical angles. And we have to write the converse. So we would say, and you can write it in typical if-then form if that makes it easier. If two angles are congruent, then they are vertical angles. Okay, number 2 says provide a counterexample to disprove the statement. If x squared is greater than 4, then x has to be greater than 2. And simply enough, you can just choose a negative number for x, like x equals negative 3, because negative 3 squared would be positive 9, and obviously that's greater than 4. Number 3 says write the biconditional as two conditionals that are converses of each other. So you're being asked to split this up into two if-then statements. It says angles are congruent if and only if their measures are equal. So one statement you could say is if two angles are congruent, then their measures are equal. Excuse me. And then you can switch it around and say if two angles have equal measures, then they are congruent. Okay, so you definitely need to be able to write a biconditional statement on your test, and you have to be able to go in reverse too. Okay, number 4, we're to supply the reasons for this algebraic proof. So they're giving us y equals 12, they're giving us 5x plus 2y equals 5. In the next step, 12 is being placed in there in place of a y, so that would be substitution. Next we have the line 3x equals 12. Well, what they did was they subtracted 2x from both sides, so it's the subtraction property of equality. Remember, don't abbreviate substitution and subtraction. And then finally, they went from 3x equals 12 to x equals 4 by using the division property of equality. You can just write division, and that's it. Okay, number 5, we have a lot of information, so drawing a picture is going to help us out with this. It says ray OB is the bisector of angle AOC. So let's just say that this is angle AOC. Alright, and OC, so this is ray OB. OC is the bisector of angle BOD, so we'd have another ray coming out here with point D on it, and this is point C. Sorry, it's a little hard to draw it neatly on here. Okay, so it says if the measure of angle AOC equals 60 degrees, find the measure of angle COD. So remember that OB was the bisector of angle AOC, And if we're given that AOC is 60, then each of these would be equal to 30 degrees. So 30 and 30. Then the next piece of information says that ray OC is the bisector of angle BOD. So this angle has been bisected by this ray. So these two angles are congruent. So if this is 30, then angle COD must be 30 degrees. Number 6, our given information tells us that S is the midpoint of RT and W is the midpoint of ST. Okay, so RS would be congruent to ST and SW is congruent to WT. It says if RT is equal to 32, so this whole thing is 32, we're asked to find the measure of ST and WT and RW. Okay, so if the whole thing is 32, RS has to be 16 and ST has to be 16 as well. So that's half of 32. Okay, that means that SW would be 8 and WT would be 8 because they're congruent. So WT is another one on our list. That's 8. Now we have to find RW. So RW would be the length of the segment from R all the way to W. So that's going to include our 16 and this 8. So 16 plus 8 gives us 24 for RW. Okay, next it says in the diagram, line segment AB is perpendicular to line segment BC. Oops, sorry about that. So let's draw that right angle in there. It says name 2 supplementary angles and name 2 complementary angles. I'm going to do those complementary angles first because I just marked that angle as a right angle. So angle 1 and angle 2 are complementary. The supplementary angles are over here. They form a straight line. So angle 3 and angle 4 are supplementary. Okay, now we're going to include angle 5 down here in the next question. And question number 8, it says angle 5 is supplementary to 4. So angle 5 supplementary to angle 4. Remember that angle 3 was supplementary to angle 4. And since 5 and 3 are both supplementary to the same angle, we can conclude that angle 5 is congruent to angle 3. Okay, the theorem that supports or justifies our conclusion is the one that says if 2 angles are supplements of the same angle, then they are congruent. And that's it. If 2 angles are supplements of the same angle, then they are congruent. Alright, number 9, last question with this diagram. It says suppose the measure of angle 3 equals 3x plus 5 and the measure of angle 4 equals 6x plus 13. Find the value of x. So don't forget that 3 and 4 are supplementary. So we can say that 3x plus 5 plus 6x plus 13 is equal to 180. So add your like terms, you get 9x plus 18 equals 180. Let's move this up a little bit, like that. Okay, so we'd have 9x is equal to 162, and then take and divide by 9. And 162 divided by 9 is 18. And that's it for that question. X equals 19. Sorry, x equals 18. Okay, number 10 is to state the theorem that justifies angle 6 congruent to angle 7. Very simply put, vertical angles are congruent. Not definition of vertical angles, don't write that anywhere ever. Vertical angles are congruent. Okay, number 11 says suppose they've already stated Angle 6 is congruent to angle 7, and angle 7 is congruent to angle 8. What property of congruence justifies the conclusion that 6 is congruent to 8? So follow the logic. Angle 6 congruent to angle 7. Angle 7 congruent to angle 8. Notice the pattern here. So angle 6 is congruent to angle 8 by the transitive property. It would be incorrect to say substitution in this case because it's congruence. There's no substitution property for congruence. Okay, finally, a little proof. Let's move this up, make some room. And first it says that we're given that DC is perpendicular to BD. So DC, which is a ray, is perpendicular to BD, which is a line. So that's given to us. Alright, in step 2, we're going to say that the measure of angle 2 equals 90 degrees. And what we're using here is just the definition of perpendicular lines. In step 3, you can say that we're given that angle 1 is congruent to angle 2, and because we want to use some substitution later, possibly, let's say measure of angle 1 equals measure of angle 2, and again that was given. Okay, in step 4, let's go ahead and do that substitution. Let's replace the measure of angle 2 up here with the measure of angle 1. So you can write the equation the measure of angle 1 is equal to 90 degrees. Again, substitution. Number 5, make our final statement. All right, we just proved that we were given that angle 2 was congruent to angle 1. Because the CD or DC is perpendicular to BD, we know that that's 90 degrees. We proved that 1 and 2 are congruent and both equal to 90 degrees, and we can finally say that ray BA is perpendicular to line BD. It's not one of our longer theorems, it's actually just the definition of perpendicular lines. And that's it. Alright, good luck with your review and good luck on the test.